In this video, we're going to take a look at conic sections. We're going to do an intro to the idea of conic sections, and we're going to talk about circles. In later videos, we'll talk about other conic sections. So first off, we want to describe what a conic section is. A conic section is a curve you get when a cone and a plane intersect. That cone is a three-dimensional cone. That's where the name conic section comes from. Now, shapes are going to differ by how the plane cuts the cone. Let's take a look at how this is going to work. By three-dimensional cone, I mean something like this, where we shoot off infinitely high and infinitely low in both directions. I've drawn one of these in Desmos, and you can see the gray conic section. Now, I've also have a plane. So here's the cone in 3 dimensions. And like I said, it goes off, if I scroll out a little bit, it goes off forever down, forever up. Okay. So that's the idea of a cone in 3 dimensions. Now, a conic section is going to be obtained by intersecting a plane with the cone. And I've highlighted the intersection. Notice that when the plane intersects the cone this way, if I look straight down upon the plane, what I get is a circular region. As I start to skew that plane up a little bit, then we elongate that circle, and that circle becomes an ellipse. It might be a little bit hard to see on this, but it is going to be an ellipse. As we get the cut of this plane even with the side of the cone, what happens is that the intersection becomes a parabola. And then as it gets bigger, then the intersection is going to cut both the top half and the bottom half of the cone, and we get what's called a hyperbola. So those are the cases where we intersect the cone with the plane at a point that's not where the tip of this cone is, where the intersection of the two halves. If you do intersect, then this way you would only get a point, a single point. And if you made the cone this direction, you'd essentially just get two intersecting lines. It's hard to see there, but you get two intersecting lines otherwise. So generally, those are called the trivial ones, where we just have a point or we have two intersecting lines. But the other ones, again, that's where we have cutting our cone in different ways. We got circles, ellipses, parabolas, and then hyperbolas. So these are the 4 types of conic sections we're going to focus on. We're going to focus on circles, ellipses, hyperbolas, and parabolas. And again, each of those is made by cutting the plane, looking at the intersection of that 3-dimensional cone with a plane. So we're going to start off by examining the graphs of conic sections in 2 dimensions. where the center or the vertex of that conic section is at the origin. And then we'll translate that. We'll shift left and right, shift up and down later. So let's start with the idea of a circle. A circle, which is centered at the origin, can be written as x squared plus y squared equals r squared, where r is the radius of the circle. Remember that the diameter of a circle is twice the radius. So x squared plus y squared equals r squared is the algebraic equation for a circle in 2 dimensions. Now, geometrically speaking, a circle is the set of all points which are a distance r from the center. So the set of all points, distance r from the center, is obviously written here in red. If we center it at the origin, that means all points are distance r from the origin. In this case, we can visually see that the radius is 5. The distance from the center to the edge of the circle is 5. So this is a circle centered at the origin of radius 5. So what we're going to do is we're going to ask questions about these conic sections. One type of question that we ask is find the features of a conic section given the equation. So something like this, example 1, it says find the radius and diameter of this circle. X squared plus y squared equals 121. We can see that this is a circle whose center is at the origin. So if we were asked for the center, we'd say the center is at the origin. The radius, well, that is going to be the square root of 121, which is 11. Now, radius is always a positive number, so we always take the positive square root of this number on the right. And then the diameter is twice the radius. 2 times 11 is 22. So there you go. Those are the features or the key features of this circle. Now this circle was nice because it was in the really nice x squared plus y squared equals r squared form. Later on in the unit, we'll look at what happens if it's not in that form. But for this one, pretty straightforward. Another type of question that we'll look at is finding the equation of a circle given some of the features. So in this example, which is example 2, we're going to find the equation of a circle centered at the origin with diameter of 18. So here we go. Basically, if I know the circle is centered at the origin, then it's going to have x squared plus y squared equals r squared as the form. If the diameter is equal to 18, then the radius has to be half of that. Remember, the diameter is twice the radius. So the radius in this case is going to be 9. Therefore, the equation of a circle centered at the origin, whose radius is 9, or whose diameter is 18, would be x squared plus y squared equals 81. 81 because 9 squared is 81. Another type of problem we can encounter is one like this. Here I see the graph of a circle, and I want to find the equation of that circle. So find the equation of the circle whose graph is given below. And if we want, while we're doing it, we can find features, or at least the key features of this circle. If you want, go ahead and push pause on the video and try to come up with that. Otherwise, I will do this in a couple of seconds. By visually looking at this graph, we can see a couple of features. First off, it looks like this is a circle centered at the origin. So I know that the equation is going to have form, which is x squared plus y squared is equal to radius squared. And then if you look closely in all four directions, we go out 6 units. So we're 6 units out on the x-axis to the right and to the left, 6 units up and down on the y-axis. So that means every point on this circle is 6 units from the origin. And that means the r is equal to 6. Radius is equal to 6 in this case. So my final equation would look like x squared plus y squared is equal to 36. And that would be my answer. X squared plus y squared is equal to 36. So there you go. We can find the equation of a circle now through given some features, but also if we look at the graph of said circle. By the way, if we wanted to know some features, obviously we're centered here at the origin. And then really the only other features of a circle are the radius and the diameter. And obviously we saw that the radius was 6. The diameter, usually denoted with a D, would be twice that. So it'd be 12. So based on the graph, we can find the equation, we can find the features. In the case of a circle, it was pretty straightforward to, if we were given an equation, to find the features of that equation. If we were given a couple of features, it was pretty straightforward to find the equation of a circle. And if we were given a graph of a circle, it was pretty straightforward to find both the equation and the features of that circle. In general, this is what we're going to be asking with conic sections. We're going to have questions like all 3 of the ones we did. We're going to find some key features of conic sections, either given an equation of a conic section or given the graph of a conic section. And then we're going to find equations of conic sections given some key features or given the graph of those conic sections. And then at the end, we'll shift the center, or we'll shift the vertex to be other points rather than at the origin. So that's it for this part on conic sections. And we'll deal with some other conic sections as we move forward.